Hello Hemant, how are you?
I'm good. How about you, Rani?
I'm good too. Can you quickly introduce yourself?
Yep. And I'll start with wishing you a happy New Year.
Happy New Year too.
Thank you. So, about me, I'm born and brought up in Kanpur. I did my schooling there. I did my bachelor's in computer science from Delhi University, and
Okay.
then started my IT journey.
Mm-hmm.
I worked in Orpheus for 2 years, where I worked as a Java Spring Boot developer,
Mm-hmm.
and then I came to Bangalore, and I worked in LAN for almost 1.5 years. Again, similar tech stack, Java, Kotlin, Block Wizard.
Hmm.
And then I joined Tenable for a year.
Okay.
It is again in Bangalore.
Mm-hmm.
And finally, currently I'm working at FDJ United for last 2 years.
Great.
My tech stack is this microservices,
Mm-hmm.
JVM language like Java, Kotlin, and I have worked with DBs as well, like
Hmm.
Postgres, NoSQL, MongoDBs.
Okay.
And in last 2 years, I have worked on Kafka as well. So
Okay.
it's an event-driven system
Got
that
it.
I'm currently working on.
So total experience, how many years you have?
Yeah. So I have in total around 6 years of experience now.
Okay, great. And I think it's completely in backend, right?
Yeah. So in Iran, I got an opportunity to work on full stack. So I
Oh,
worked
great.
on jQuery, React as well for like 6 months. So I
Okay.
have hands-on on front end as well. But I
Oh,
will call myself as a back-end developer.
okay, perfect. Okay, so it will be like a completely DSA round, and I will be asking one question and maybe few follow-ups on that question. Like you can share your screen and you can open Google Docs.
Yeah. Is my Google Doc visible to you?
Yes, I will share you the question in chat. There will be an array and target. You have to check at what index that target is present, and this array will be a rotated sorted array. Like, uh,
Mm-hmm.
hmm,
Okay. So the input is rotated sorted array 457, and then the rotation happens 012, and the target is 0, which is present at output 4.
right.
Hmm. We need to return the index of target
Index
if
of
it
the
is
target.
available, or else it is -1.
If the target is not present, we'll just return -1.
Hmm. Just let me read it. Ascending orders, number is possibly left rotated. Then such that setting area is sorted, and if this one is left rotated by 3, that's 4, 5, 6, 7, and 0. Target is 0. So the first thought that comes to me by looking at the question is that
Mm-hmm.
it's a sorted array. It's
Right.
just that it is rotated few times. So when
Hmm.
we see it does not look sorted, but it is sorted if we remove those rotation.
Hmm. Right.
So, and whenever we have the input array sorted, then usually we go with binary search.
Okay. Hmm.
That is the first thought that is coming to my mind by
Hmm.
looking at the question.
Right.
Yeah. If we have to apply binary search here, mm, yeah, but this is not a normal binary search, so it's a variant of binary search.
Right.
we can't just use the normal one. Like if this was the test case, then the
Hmm.
normal binary search would have worked. We could have taken this as left and this as right, and then we could have calculated mid.
Hmm.
It would be 2 and the target was 0. So then again, we could have moved right to this side, right pointer, and then again calculated mid using left and right, which is 2. Mm, yeah. But this is a variant, so the normal binary search won't work.
Right.
Mm, so we have to think of the new cases that are present here.
Hmm.
And there are just few questions here. So
Yeah.
always the array is rotated, or it could be that
Hmm.
sometimes array is rotated 0 times, or it is rotated more than the length of that array itself.
No, the array is always rotated. It will not be a case that it's rotated 0 times in this case.
Mm. But the rotations could be more than the size of the array itself. Like in this case, the size is 7, so we could have a case. Okay, but yeah, I see. Even if we have 10 rotation, it will be 3 rotation only.
Hmm. Right.
That is not the crux of the problem then.
Mm-hmm.
Okay, so we need to focus on the direction of sorting them. So here we could see it is like increasing, and then so this part is sorted in this test case, the left part, and the right part is also sorted.
Right.
So
Uh,
we need to find out the case, like both different cases. Yeah, go on.
yeah, so you are thinking correct about binary search, but let's try to apply binary search and see which part is sorted and which is not.
Mm, yeah. Looking at the first, looking at the input test case, the first part is sorted, but how do we figure it out via code?
Mm-hmm.
Let's see. So we need to compare, I think, left and mid. That should give us an idea whether we have the first part as sorted or we have
Hmm.
second part as sorted. So if first part is sorted, then we need to find whether the target is within those boundaries.
Hmm.
So I'm just writing the conditions at the moment.
Sure.
Then later I'll translate it to the pseudocode.
Hmm.
So if left part is sorted, then we have this case where A of left is less than A of mid. And then we need to find whether target is between this or not. How do we figure out if target is within the boundaries?
Mm-hmm.
Mhm. Target is in this case 0, but it is not in this. Even though left part is sorted, the target is not present. So target should be if E of left is greater than target,
Mm-hmm.
and E of mid. Mhm. Suppose target was 6, so if mid would be greater than that. A of left would be less than. If it was 6, it would be this case. Target is greater than left, so this is the boundary. That's how we know that this is within this. And we'll do. So here I'm just trying to write a case if we were searching for 6.
Okay, you are considering target as 6.
Yeah.
Okay.
So that I can just figure out the
Hmm.
conditions if target is within the boundary of left part or right part.
Okay.
If it is within the boundary, then what we need to do? We need to bring back the high this side. High, or we could say right.
Okay, yeah, we'll move to the left then.
Yes, so this is basically that we were searching for 6 and we know left part is sorted and it is within the those boundaries.
Okay.
So we will bring back our right in this side.
Okay.
Right. Mm, So what was left and right? 0, 3, 4, 5, 6, 3. So 7 was mid, which is 3. So right becomes mid minus 1, so 6. Yeah, nice. So A of mid would be 6, which was our target. I'll write else case as well.
Mm-hmm.
If the target is not in the boundaries. Mhm.
Let's say the target is 1 or on the other side, and you are on
Yeah,
7.
yeah. So this means that we need to move towards the right side of the array.
Mm.
Would be left equals to mid plus 1. Mhm. Need to maybe run it through one test case.
Oh, yeah, we can have a dry run in one of the test case.
Yeah. So this is if the left part was sorted, but
Hmm.
the other way is if right part was sorted, then what will do?
Yeah, you can take maybe another array, a different array, and see.
Yeah, I think in this case target was maybe not in the boundaries and we move left equals to mid plus 1. I think this looks fine.
Mm-hmm.
At a high level, this looks fine.
Mm-hmm.
Let's move to right part. Yeah. Said we can take a new input. Okay, so this time we will rotate it and make the right part centered. Mhm. Let's make it 11. Yeah.
Hmm. Okay.
So this time the right part is sorted. So
Hmm.
we have made a 7 on this one. Okay. I think the loading would be very similar only. Mhm. So if right part is sorted and we are searching for maybe target 9.
Mm-hmm.
We need to again find whether the target is within the boundaries. So what are those boundary conditions? Target is 9, which means A of mid is actually less this time.
Mhm.
Way of right is actually greater. So this means it is within the boundaries and we need to bring back the left part here. Hmm. Then this. Let's what
Let's
was the
dry run this
yeah,
code properly on one of the any one of the array.
yeah. It's just trying to figure out whether the else case is right or not. I
Okay.
know the if case, I think that I
Mhm.
have written correctly. If the target is within the boundaries of right part,
Mhm.
this would work. But if we search for 12 and the target is not in the boundaries, we need to go to left part, which is yeah, right equals to mid minus one. That makes sense. Yep. So think at high level, this is the algorithm, but you want me to run through this original test case.
Let's say initially itself in mid, you got the target.
Mm-hmm.
So in this algorithm, there is the condition for that.
Yep. Yeah, so that is the best case.
Uh, like
Scenario.
target is let's say 7 for the
Mm.
array.
Yep.
Mm-hmm.
As soon as like, there are two things coming to my mind. Shall we check whether left and right are already sorted, but there would be rotation, so they would always be misplaced.
Like
Let's ignore that.
initially target is equals to mid, array of mid.
Mm-hmm.
So I mean, then do you want to do
Yeah,
all of this?
yeah. Then I guess
Mm-hmm.
we would be at here mid equals to
Right.
left plus right by 2 and we will see that it is already the target element.
Right. Mm-hmm.
So that will be a base condition of binary search when the binary search ends.
Hmm.
I think I forgot that part.
That's fine. Also, one
Mm,
more thing. When does this loop ends? Like, I think it's a loop, right?
yeah.
Mm.
Yeah, so I was just thinking in an algorithm step and
Right.
so I forgot those left and right things. So this is like a simple template of
Mm.
binary search. It starts with left and right and then we first calculate mid. If the mid is already target, go to the
Mm-hmm.
best case.
Mm.
Now our specialized version of binary search comes into picture because this array is sorted. So we need to figure out if it is sorted in left part or
Mm.
right part. It could be only either because there was rotation that happened. So
Mm.
if left part is sorted, then we need to figure out if the target is within the boundaries of left part.
Mm. Right.
We know it is sorted, so
Mm.
okay. So here you could imagine a condition like this. Mm, okay. So if it is in the boundaries, then we will move the right pointer here because we know this is our sample space we need to search. So right will come here, mid minus one, and then we will again run what is the
Let's
new mid.
so one more thing. Let's say left is at 6 and
Mhm.
maybe left is at 5 and right is at 6.
Mhm.
I'm just thinking if the while loop condition we have to add less than or
Yes, that was the thought that was coming to my mind. Whether
hmm,
we need less than or equals to, but yeah,
we can try run
we can
and
only
check.
figure it out after the dry run.
Yeah, yeah.
Okay. So if the code looks good, then Guess I will do the dry run.
Yeah, we can do the dry run.
Good. So I'll take the test case that was mentioned in the question itself.
Hmm.
Output is 4, target is 0, so it is in the right part. Okay. So as per
Can
our
you
clue, let me.
mention exactly that left is zero, right is
Okay.
like the whole dry run properly?
Yeah, sure.
Hmm.
Sounds good.
Hmm.
So left equals to 0, right equals to size minus 1, size is 3,
Hmm.
4, and 7. So right becomes 6.
Hmm.
Left is less than right, which is true, 0 is less than 6. Mid becomes 3 in the first iteration.
Mm-hmm.
6 plus 0 divided by 2. We will see whether mid is target. Our target was 0, which is at 4 actually. So we missed the target. We need to find whether it is that left part was sorted or right part was sorted. So
Mm-hmm.
we will see A of 0 is less than A of 3.
Hmm.
Yeah, it is true. Actually, the left part is sorted in this question.
Hmm.
So A of 0 is less than A of 3. This is trirem, which means 4 is less than 7. It's
Hmm.
true. So we will see whether the target is within the boundaries or not.
Okay.
So target is 0 and we are looking at 4 and 7. So it is not in the boundaries because target.
Mm-hmm.
So this condition is false actually. So A of 7, I mean A of mid which is 7 is greater than 0 and target is not greater than left. So 0 does not lies between 4 and 7. So we will go to the else part. This part is false. So left becomes mid plus 1. So mid is 3, it becomes 4. So that was our first iteration of dry run.
Mm-hmm.
So we will see left and right now. Left is 4, right is 6 this time. So mid becomes 4 plus 6 divided by 2, which is 5. 0, 1, 2, 3, 4, 5. So we have reached here actually. Okay. So A of mid is 1. We will see whether the left is sorted or right is sorted.
Mm-hmm.
First, we'll see whether A of mid is target, which is not, because A of mid is 1, target is 0, so this is false. So left and mid will be compared. Left is actually 4 this time. So this is 4 and this is mid.
Mm-hmm.
1 second. Mid is actually second iteration. I got a bit confused. Mm, okay.
Left and right and mid is five. That is one, right?
Yeah, let me remember.
Mm.
Sorry. Left is 4, right is 6, mid is 5. A of mid is not the target. A and left, A of left is actually 0. A of mid is 1.
Mm-hmm.
So 0 is less than 1, which is true. So as per our algorithm, our left part is still sorted. Because
Mm.
yeah, our array is divided into small part only. And as per this, the left part is sorted. And we will see whether it is in the boundary or not.
Mm.
So 0, we were searching for 0 and whether A of left and A of mid is greater than target, I don't think so. So 1 is greater than 0, but 0 is not greater than.
So So we are comparing 0 is less than 1, right?
Yeah, so there are two conditions here. First, we identified left part is sorted,
Yeah.
which is true.
Hmm.
Now, here A of mid is greater than target. Like A of
Hmm.
mid is 1,
Hmm.
which is greater than 0, which is true. But the first condition, A of left is less than target.
Hmm.
So A of left was 0 and target is also 0. This is false. Like
Right.
0 is not greater than 0.
Hmm.
So target does not lies within the boundaries. So in this case, else part will be left equals to
Hmm.
mid plus 1.
Okay.
So now left becomes 5. As per after the end of our second iteration,
Hmm. Okay.
left becomes 5, and again we'll see whether 5 is less than equals to 6, which is true. Mid equals to 5 plus 6 divided by 2, which is 5. 11 divided by 2, and the floor. So this time we have made is, I think, 0, 1, 2, 3, 4, 5.
Mm-hmm. But you are
So it
mentioning
becomes,
index only, right? In left, right, and mid.
yeah.
Okay. So mid plus 1 means left will be.
Oh, I see.
Mm-hmm.
Think I must have the dry run a bit.
Fine.
Mm, okay.
So we can check the else part. Like I think in the previous loop, it went to else equals to
Mhm.
left equals to mid plus 1. So what
Yeah.
was mid earlier? Just 2 plus 1.
Oh, I see. The mid earlier was it 5 itself?
5.
4, 6. Can't seem to remember. First it was 0 plus.
Maybe in the like wherever you are making an array on top of it, if you mention the indexes as well, so it will be easy in try run.
Mhm.
Like
Yeah.
wherever the array is there, right? On top
Yeah,
of
I
it,
think what
just
I could have done here, yeah, sorry to interrupt. What I could have done here better was just write the current
huh.
iteration. So I was keeping track of all the iterations, like
Calculations,
first,
right.
second, third, and that's why I messed up.
Mm-hmm.
If
Right.
I would have just taken the track of current iteration, therefore.
Mhm.
Mhm. Okay. Do you want me to start from the beginning or?
It's fine. You can start from 0, 1, 2 as well if you want.
Mhm. I think with the current approach, I think I messed up the indexes at
Mhm.
different iteration.
Okay.
So probably what I'll do, I'll take a step back and I'll start from beginning. And this time I'll probably maintain only the current left and right so
Hmm.
that I don't get confused.
Sure. You can go ahead.
Okay. Cool. So this was our array, and then we had left equals to 0, right equals to size minus 1, which was 6. So our array was of size 7, right index was at 6, first condition was true, mid became 3,
Okay.
and the mid was not target, target was 0, which is present at fourth index,
Mm-hmm.
but mid is at third index, so this condition is false. Now
Mm-hmm.
we will figure out whether the left part is sorted or whether the right part is sorted. So A of left, which is A of 0, which is 4, and A of mid is 7, so 4 is less than 7.
Mm-hmm.
means the first part is sorted. So we will go to this if block. Now we will identify whether our target is within the boundaries of the left part only or right.
Hmm.
So A of left was 4 and target is 0. And then A of mid, which was 7, it
Mm-hmm.
is greater than 0. So this condition is false because the first condition is not true. So this if case won't run.
Mm-hmm.
0 does not lies between 4 and 7, which is true. So else condition will run and left equals to mid plus 1. So left is now 3 plus 1, which is 4. So that is the end of first iteration, the first pass.
Mm-hmm.
And what we came to know that our element is not in the first half. Left is 4. It means that in our right side of the array, the
Mm-hmm.
element is present, the target is present.
Okay.
So now we will start with this. I'll remove these values. Okay. So left is 4, right is 6, mid becomes 5 this time,
Mm-hmm.
and A of mid is 1. It is not the target, so we have not hit the base case yet.
Mm-hmm.
First we were searching for 0, which is index 4. So again we will see whether left part is sorted or right part is sorted.
Mm-hmm.
So left is 4, right is 6, so left is 0, and right is 2. So this condition is true. Our left part is sorted, like in the smaller version of array that we have, the left part is sorted.
Mm-hmm.
Things are clear till now.
Yeah.
So now we will see whether the target is within the boundaries or not. So A of left, which is 4, 4 is actually 0. So whether 0 is less than 0, which is false itself. So first condition is also false. So we can skip the second condition because false and true will make false. So we
Mm-hmm.
will go to else. Left is mid plus 1. So left was 4, it became 6 now. Actually. Mhm. I'm doing everything correct here. Mid is 5, left becomes mid plus 1, and right is also at 6.
So, what do you
Mm,
think? A left less than target, where the condition where we are checking below this, if a of left is less than target, zero is less than zero.
Okay.
So here, so can you think like where we have to actually move when we are at one? We have to move left or right to get to target.
Yeah, I think ideally we have figured out that this index lies here.
Hmm.
So our mid was here, left became this.
Hmm.
I think it should be moving towards this. Right should be becoming mid minus 1. Yeah, this condition could have been true, actually.
Hmm.
I'm thinking of putting equals to here.
Hmm.
If
Hmm.
we put equals to here, then this will actually become true. And
Right.
our right will become mid minus 1. So instead of left equals to 6,
Hmm.
we will be getting right equals to mid minus 1.
Hmm.
So right was 6, right became 5. Okay, so if this works, then I guess the right part also we need to do
Hmm.
something similar.
Yeah.
So right is 5
Mm-hmm.
now after the feedback that you gave, I think.
Hmm.
If we put the equals to right becomes 5 and then mid becomes mm, left was 4. So this time It is actually 5, 4 plus 5 plus 2, this time it is 4. And finally, our base case is actually true.
Correct. Okay.
So we finally got to the end and returned 4.
Hmm.
But it took us, I think, 3 iterations actually.
Hmm.
It took us 3 passes to reach here. But
Yeah.
it is still better than the linear. If we
Linear.
would have taken linear, it would have taken 5 passes
Hmm. Right.
because boundary search is
Hmm.
used to divide the array into like 2 parts. That is why we were able to do it in 3 passes only.
Hmm. Can you also explain time complexity and space complexity for this algorithm?
Yeah, sure.
Mm-hmm.
So the time complexity is log n.
Mm-hmm.
Because we are dividing our input into 2, so log n base 2,
Hmm. Okay.
which is better than linear size. Big O of n would have
Yeah.
been worse in this case.
Mm-hmm.
In the space complexity, I think we are only using left pointer, right, mid, so it's not even. So it is constant big O of 1 only, I guess.
Okay. Yeah. Perfect. So in this question, we were having unique elements, right?
Yeah.
Yeah. But let's say we have some duplicates as well. Let me give you one test case. Yeah, so let's say we have some duplicates as well. So previously in your algorithm, we were comparing the mid and left and finding out which is the sorted part, right?
Yeah.
Yeah, but in this case, how will you actually find which is sorted part and go through that?
Okay. So we still have something we need to search in this array.
Mhm. So in this, we can search, let's say 3 is the target. So
Mhm.
you just have to return a boolean if it is present or not, true or false.
Okay, so something like this.
Right.
So we have an input, but this time it contains duplicate elements. And if we have the target inside, then just return
Hmm.
true. If you don't have it, then return maybe false.
Right.
Mm, The name approach that comes to my mind is
Mm-hmm.
mm, since we have duplicate elements, but yeah, I was thinking of integrating set here, but again, we have to iterate everything and that becomes big of and
Right.
the time complexity will suffer. But I guess here we need to again do it in big of login only.
Yes, beautiful. With the same complexity. Hmm.
Yeah. So again, searching question which will probably involve binary search, I think.
Right.
But the thing here is that input is not sorted in this case.
Mm-hmm. The issue will be only when these three are equal, right? Let's say it has duplicate, but the
Mhm.
duplicates are not in starting and ending. Let's say it's just 3, 4, 1, 1, 2. Then your algorithm might work in this case, right? Whatever you have
Yeah,
written
it becomes sorted. Yeah,
previous question, it might work
yeah,
here.
it's rotation only. Mm, but in this case, okay, I see. So this is again a rotation question only if you look at it. But
It's the same question, just we have duplicates.
instead of unique numbers, we have duplicate. And will our current code work?
Yeah, that you can check if we can apply a few conditions on top of it.
So in our current approach, what we did was we figured out whether left part is sorted or right part is sorted. And then we search for target, whether the target lies within the boundaries.
Hmm.
So this test case, take a look 34112. So here if we search for one
Hmm.
exists, but as per our current code, what will happen is we will see whether the left part is sorted, it is not. We'll see the right part is sorted, so our else part will finally work.
Mm-hmm.
Mm, and then it will find, yeah, it's gonna find one in the next iteration only. Yeah, so this test case, it will actually pass. But what about this test case? I'm now thinking like we just dry run our code for the like dry run the above code for
Hmm.
this test case. It will actually work without any code changes.
Right. So the
But
issue
this
is
test case is confusing.
so the issue is if the starting, middle, and end both are same. So can we do something in that case?
That's
And
not
you are
very clear.
already checking if mid is equals to the target.
Hmm.
Mm-hmm.
So the code will actually work for this test case because that first
Mm-hmm.
line only it will figure out that mid is the target. But
Uh,
yeah, one
right.
thing that you mentioned was if we have left, right, mid, everything is same, so we will not be able to figure out whether the left
Yes.
part is sorted or right part
Right.
is sorted. That is the thing I'm
Mm-hmm.
not able to find answer to.
Mm-hmm.
Yeah, that is the problem with our current implementation. We are relying on left, right, and medium to find the sorting pattern.
Mm-hmm. But
But
let's
maybe
say let's assume the
yeah,
target is 4 in that test case. Because in 3 it will just get the mid and
yeah. Yeah,
mm-hmm.
if the target is 4, our code will run into time limit exceeded because it will never be able to come out.
Mm-hmm.
That is the thing.
It's true only, right? Output. Mm-hmm.
True, but the current code implementation will be giving false.
Hmm.
How do we make it true? Shall we do a dry run of this?
Yes, we can.
Figure it out. Just to figure out what are the problems with the current implementation.
Hmm.
Because if we know the problem, then we'll probably arrive at solution.
Yeah.
What we noticed was that our right part also needs this. Cool. Yeah, let's start.
Hmm.
So this time size is 5, left is again 0, right is again 4. Mid becomes 2 actually. 4 plus 0 divided by 2. And A of 2 is 3. which is not our target element. So we will enter this part. We will figure out whether left part is sorted or right part is sorted, and this is where our current implementation use breaks.
Hmm.
Because left is 3, right is 3, mid
So
is also 3. So
one
our
thing
code,
to notice that we already checked mid is not equals to target,
yeah.
right? So that three, which is in starting and ending, that also is not target, right? We don't actually need that starting and ending in that case.
Mm,
Can we change the left and right too? Because three is anyway not the target.
okay. So in binary search, usually left denotes the endpoint.
Mm-hmm. Then after,
Okay, I see.
Mhm.
I see. Because this is a custom implementation, maybe then we
Mhm.
have to probably check whether left and right are equal or something like that. Left, right, and mid are equal. And based on that, we could change our current implementation.
Right.
Yeah, fair point. That what is the change that we need to do? So here we figured out if mid is not equal to target. So we need checks for left, right, and mid. Mid, mm, mid I'm not sure about. Because if we had a test case 3, 4, 3, yeah, then we would have got to. I think we need a check for all three places.
Yeah.
Mm. So instead of finding whether the left part is sorted,
Mm.
we could, because we know there are duplicates, so we could have if left is equals to mid, something like that.
Yes.
And based on that, we could make the code changes. So if left is equals to mid, then we need to probably find a new left and mid.
Right.
Okay, but what could be the alternate left? The naive solution that is coming to my mind is just move left
Yeah.
to some other position plus one.
Right.
Mm, okay, let's see. We have to keep some faith in our code.
Mm-hmm.
Find a new left and recalculate mid.
Mm.
Mm, but if we do it for left, then we need to do it for right as. But that part will come later. No. So we will recalculate mid, which means how do we send it back? Okay.
Or maybe we can just continue and the below part.
It will automatically will
Hmm.
come to this part.
Hmm.
So we need to write our if condition in such a way that
Hmm.
the situation ends here only.
Right.
There is no if else in the bottom that could run.
Hmm.
Mm, okay, what do we do? Suppose this was the end. We again came to the start. Left became 1 this time, right became 4 this time. Size 5, mid will become 4 plus 1, 5 divided by 2. Again, it's the same value. Yeah, it again becomes two, but this time this is not just good.
Mm-hmm.
So A of mid is 3, but we were looking for 4s, so we don't need to modify our left part. So this time we need to figure out which direction do we need move. First left is at 1 actually. Okay. The next solution again that comes to me is also check whether left is target or not.
Means you recalculated a new left, right? And then other
Recalculated a
condition
mid, yeah.
means left position we changed, and the loop was
Yeah.
starting from again, and 4 and 3 are different, right? So I
Yes,
think the
exactly. So
other
let the thing.
conditions is means it is of previous solution only, right? If left and mid are not
Mm,
equal,
oh, I see.
then you will be able to know which part
Oh, I
is
see.
sorted. Mm-hmm.
I see. So if we just add few checks in our current code, then we
Hmm.
would be good to go. So if left part is sorted, so left is 4 and mid is 3, so it is not sorted actually. So it will go to else part.
Mm-hmm.
It will check for whether right part is sorted.
Hmm.
Right was actually 4, just 3. So 3 and target. Target is 4. Let me write it. Else I will get confused again. Okay. We are at this part and we know that right part is sorted this time
Mm-hmm.
because left part was not sorted. So we need to figure out A of mid. A of mid is 2, which is 3. A of right is 3. Okay. Oh, I see. Now we are written that condition. Now this time we have the exact same thing but for the right part.
Hmm.
Now the problem is that mid and right are equal.
Hmm.
Earlier our problem was left and mid are equal.
Right.
So we can do something like this. So in our right part also, if we write this test case, if we
Mm-hmm.
write this if condition,
Right.
if right and mid are equal, then do right minus minus and again go back and recalculate mid.
Can we combine these two conditions on the top itself?
Oh, I see. Yeah, just to I think make this code a bit clear and
Mm-hmm.
concise, we could have those conditions at the top itself.
Mm-hmm.
So before checking whether the left part is sorted or right part is sorted, we need to find whether left and mid are same or whether right and mid are same.
Hmm. I
Based on that, we could
see.
just
If left and mid are same, like let's say middle element has 3 and starting
Mhm.
element has 3, so in between all the elements must be 3, right? Because it is rotated. It can't be
Mm,
that right can be something else. If
yeah,
mid
we could.
and left matches, it means right is also same.
Mm,
Because we
your
can't
point
have
is fair.
anything different. It's rotated and sorted also. Hmm.
Yeah, because our input test cases are made in such a way that we will always have the repeated element in one direction.
Hmm. Right.
Because actually this, and after we have the new element, the next element won't come. Yeah, that's a fair assumption.
Mm-hmm.
That could help us. Okay. So if we write that at the top itself, right will become actually right minus minus, right was 3, right was 4, right becomes 3 now.
Hmm.
And again we will do this recalculate mid. Left was 1, right was 3, mid becomes 3 plus 1 divided by 2, which is again 2. And 3 plus 1, yeah, it is again 2 actually. Okay, so again mid is 2, we will have left is less than right, 2 again, it becomes 2, mid is not the target. Now
Hmm.
we are looking for 4, but it is 3. So we will have our new checks in place. Whether left is equals to mid, no, left is 1, which is 4, and mid is 2, which is 3. But this condition is true actually.
Mm-hmm.
Mid is 2, right is 3. Again, we have the same problem. Right and mid are equal, so this code will actually again run. Just assume that this is present at the top only.
Hmm.
So right again gets decremented
Hmm.
to 2. Finally, now we have a different mid. 1 plus 2 divided by 2, 3 divided by 2 becomes 1.
Mm-hmm.
So mid becomes 1, and this time our code will run into base condition.
Hmm.
So mid is 1, target. Yes, mid is 4, target is 4, so returns mid. But again, it took us 3 iterations to reach here, which is still better than 5.
Hmm.
Because if we would have done linear search, in
Yeah.
worst case, it could have taken 5. But this time we ended up with 3.
Right. I think
Yes,
works.
it was a good variant.
Hmm.
I have not came across this question earlier, so
Okay.
learn the new things.
Sure. You can stop sharing. So it was really great interviewing you, Hemant. So, according to me, you were really good at problem solving. I think initially the first problem, the way you were thinking, the approach, the way you broke down the approach, it was really good. And eventually, of course, you reached to the solution. So it was great. One thing I noticed in the dry running part, I would suggest to keep if it is in Google Docs or if it is in any other platform, to keep it really clean, and you were calculating the index of the array again and again. Right, so again, it's your 1 minute wasting or your few seconds wasting in that, which in interview we should not do. Just kind of write down the indexes of the array on top, so you don't have to calculate the mid again and again or anything, just to save like a little bit time, which will eventually help you only. So just that dry running part, I think maybe Google Doc practice you don't have, or maybe you can practice on that more. Uh,
Yes.
so I think, yeah, apart from dry running part, it was really great. The way you were explaining your thoughts was good. That has to be done in this kind of interview. So I really appreciate that part. So how did you feel about this interview? Can you tell?
I think, yeah, sure. First of all, thanks for the feedback. I agree. I
Mm-hmm.
was not good with the dry run initially
Mm-hmm.
because I'm not familiar with the Google Doc approach.
Okay. Hmm.
We are usually writing the debug statement system.out.println in our code. And
Right.
that's how we debug. But
Mm-hmm.
debugging on your own on that Google Doc is a bit tricky. Yeah, it's
Right.
a fair advice that if I would have written just the indexes
Hmm.
of those elements, then I could
Hmm.
have just seen that and I didn't have to do that recalculation in my head. But
Right.
I could have saved few minutes. Yeah.
Hmm.
Yep. And apart from that, I think that was a
Mhm.
good feedback that you gave, and that's all. I have nothing to add.
Okay. Also, I would like to ask, what advice will you give to those who want to transition from SD1 to SD2 or some senior level, as you have like 5 to 6 years of software engineering experience?
Yep.
Mm-hmm.
So if somebody who is junior is watching this video, probably
Mm-hmm.
think bit of advice for them if they are looking to reach the senior level SD2, SD3
Mm-hmm.
is that mm, usually a junior developer focuses on their code, their problem statement, their task, their Jira ticket. They
Right.
have that narrow mentality
Mm-hmm.
and they just raise PR and
Hmm.
call it a day. But if you are looking for a senior position, then I guess you need to take more ownership and accountability.
Okay.
So you need to look at the other people PRs as well,
Okay.
especially your seniors, your staff engineer. You need to see those code, how they write their code,
Hmm.
and probably you can comment on their PRs as well.
Okay. Hmm.
And as a habit, you should develop that you should always be challenging your seniors' decision. If
Hmm.
they have taken decision to go with a NoSQL DB like MongoDB, then
Hmm.
why they don't do Mongo? Why not maybe AWS DynamoDB? So always have that challenging
Hmm.
question ready for your seniors. That
Right.
will also give you visibility. Like
Hmm.
a junior is curious enough to ask those questions.
Right. Okay.
Yeah, that will be the, I think, a small advice from my end.
Hmm. Also, I see that like in this span of 6 years, you have switched companies, right? So in every switch, you might be preparing and giving a lot of interviews. I think you would have a lot of experience of interviews as well. As today, also after interviewing you, you were expressing your thoughts very clearly, which I really liked it. Many of the senior developers or junior developers are not able to do so. So, how can someone practice for the same or expressing the thoughts in this kind of situation is really tough. So, any
Yeah,
advice for that?
I think the word that I'm looking for here is articulation.
Mm-hmm.
So, how do we articulate our thoughts in a manner that interviewer is able to get it?
Right,
So, which is it comes from practice itself. So,
right.
whenever in your company you are getting an opportunity to speak, you'll
Hmm.
give a demo, to give a presentation in front of stakeholders to
Hmm.
get a practice. The first time you will feel nervous, you will have butterfly in your stomach, but maybe five, 6 times if you do it, you would get eventually good at it.
Okay.
So as a senior, you should be also good at speaking
Hmm.
and you should be able to probably present your work in a manner that stakeholders understand because stakeholders are not technical people. They don't know this Java, C++.
Right.
They
Hmm.
only know their product and features. So speak in a manner that also higher level is able to understand. So it comes with practice.
Hmm. Got it. So, if you are able to explain to stakeholders who don't know about coding, so you'll be definitely able to explain the interview.
Yeah.
Got
Yeah.
it. Okay, okay, Hemant. It was really great connecting with you. Thank you so much.
You should. Same here. I think I learned a lot and I needed this kind of mock interview to just get confidence and
Thank
just
you.
get good at solving the DSA problems. Thanks for the opportunity and I wish you all the best. I hope your channel grows
Thank
very
you.
fast. Bye.